going to have to move forward. This is an interactive panel, so if you guys want to come forward, it's okay. We won't bite. So good morning. My name is Erin Gutierrez. I'm Senior Manager of Sustainability at Boeing Commercial Airplanes. My background is in acoustics. I got my undergraduate at Purdue, my graduate at Penn State. At Boeing, I have led acoustics. I've also led the Eco Demonstrator Program and now lead sustainability for our product development group within Boeing Commercial Airplanes. Today we're going to talk about how we design sustainability into the next generation of aircraft. We're going to explore kind of that broad landscape of sustainability. Sustainability is a systems of systems complex challenge, and we're going to talk about some of those complexities today. Our world is changing pretty quickly from policy to climate, and we really want to explore what that does to the design of our products. We're going to think about sustainability very broadly, so not just the emission side of it, but the development that meets the needs of the present without compromising the needs of future generations. With that, I will introduce my co-monitor, Atherton.
Thanks, Erin. Good morning, everyone. Welcome to the panel. My name's Atherton Carty. I have the privilege of leading the strategy and business development organization for the Skunk Works, which is the front-end portion of the aeronautics company within Lockheed Martin. So we just passed our 80th birthday, so it's always been a privilege to spend the lion's share of my career as part of such a neat, iconic institution. Most of my career, my 27-year career, has been focused on the technical side, S&T, analysis, experimentation, test, design. So I think of myself as an engineer and a scientist by trade. But it's been kind of interesting the last couple years. I've gotten to kind of flip the script and really focus and pivot to a customer-facing external side and really look at more of the strategic long view. And as I've gotten out more and more and connected in particular with some international customers, one thing has become clear that the sustainability topic is really starting to come to the forefront. It's kind of at that point where it's shifting from what seems like a nice to do or a nice to have to a have to do and a have to have. And so I think that pivot, if you will, at a macro scale is one of the areas that we want to really focus on as part of our panel. And I'm pretty excited to be part of this conversation because when Erin and I were talking about, well, what are we hoping to get out of this time that we're spending together? What does success look like? One of the things we came away with is, well, it would be nice if everyone that's taking part on this journey with us leaves with kind of a self-reflection of where they fit in the equation, because it kind of becomes similar to the narrative around topics like quality or safety or cybersecurity. It takes everyone, right? It takes a village. Everyone has a part in making this sustainability journey successful, right? So one of the things that you can take away from that comment is that there's a lot of connectedness that we have to kind of take stock of. And so we've enlisted the help of a partner, one of the companies that you've seen in the tech hall over the course of the week, Shark Cloud, that has been very instrumental, or will be very instrumental in our conversation today. They're going to help us to facilitate this discussion around how do things connect? So what does the software do? Well, Jason's going to take us through it in a few minutes, but the way I would describe it in layman's terms is it takes disaggregated or disparate ideas or technologies or concepts, and it helps to show the connectedness between them. Where are the linkages? What is that one thing that has that 6 degrees of separation that connects to everything, right? So that connectedness is going to be central to our discussion. It's going to be central to the expertise that ties all of our panelists together today. So we're going to start by having you spend a little time and hear from each one of our panelists, subject matter experts in their own respective fields. And then we're going to kick off with some of our own internal questions, and then we'll start taking your questions. So I've been entrusted, kind of frighteningly, with the Q&A iPad. So as you start to hear the content that we're walking through and that our panelists are sharing with you, don't be afraid to put a question in, and as we get to the second half of our time together, we'll start to make our way through those as well. So with that,
great. Thank you.
I'll pass it off to our first panelist. Adam, over to you.
All right, good morning.
Good morning.
So, Yeah, I'm here to discuss a little bit about sustainability across the value chain. And it's a little bit different, maybe, than several of the other speakers here today. So let me first thank AIAA for giving me the invitation to be a part of this panel. I think it's going to be a really fantastic discussion today, so I'm really excited about it. Let me first tell you just a little bit about myself to set the stage here. I graduated about, 3 decades ago now, with a degree in geology and climate scientist. Any geologists out there? Yeah, I didn't think so. I'm probably the only geologist at an aviation conference, but hey, we'll give that a go. Went on to spend about 10 years in consulting, doing environmental compliance consulting, and then worked for Cummins Engine Company for about 15 years in a variety of roles in environmental compliance, and then moved on to sustainability and environmental policy. Spent a fair amount of time in DC on sustainable policy issues and helped grow their sustainability practice. I then went to BAE Systems, where I was Vice President of Health, Safety, and Environment and Chief Safety Officer. And in that role, I was responsible for growing their sustainability practice as well. I'm now a principal consultant at Haley & Aldrich, where I get the opportunity to work with a lot of different companies across a lot of different industry sectors on sustainability and the challenges of sustainability. So why do I tell you all that? I'm going to spend some time on a couple of topics on the regulatory environment, how fast things are really kind of taken off, and the importance of looking at sustainability across the entire value chain. And hopefully some of that experience, especially when we get into the panel discussion, will be helpful. So let's jump in. So why focus on the value chain and not just inside your four walls? Well, about 70 to 90% of your greenhouse gas emissions in most companies comes from scope 3. Let me stop for a second and define the scopes to make sure we're all on the same page. So greenhouse gas is accounted for in 3 scope areas. Scope 1 is direct emissions from your facilities, so think fuel burned in your vehicles, natural gas for heating, so kind of inside your 4 walls, if you will. Scope 2 is emissions from energy that is used inside your 4 walls, but the emissions are somewhere else. So think electricity is probably the best example of that. You use the energy, turn the lights on, but the emissions are at the power plant, right? And then scope 3 is everything else in your value chain. So from the mining of the minerals at the beginning of your product life cycle, through manufacture, through distribution, through product use, to end of life, all of those emissions. And that's why it often represents such a huge portion of your GHG footprint. So you also need to understand the social and governance risks in supply chain, and we'll get into that a little bit. Emerging regulations, we're going to talk about that as well, and what this means for your value chain. Many suppliers have really not had to deal with, nor maybe they don't have the resources to deal with the sustainability challenges that are coming. And so companies must understand that risk, they must manage those requirements, and they must help engage their suppliers to be successful, because you won't be successful without them being successful. So let's talk about a few of those drivers. You've got investors and financial institutions and the value chain itself and your markets and customers. So investors and financial institutions are spending a lot of time looking at and asking for data on the risks associated with this. So they recognize sustainability as a financial risk to these companies. And in the value chain, we're going to talk a bit about those risks as well. You've got your supplier and customer GHGs that we talked about, human rights risk. Did anyone see the story back in March from John Deere, a great company that's got a good sustainability record? And one of their suppliers was caught with underage, undocumented immigrants working in their factory. And what did the headline read? John Deere, right? It's really a significant risk in the supply chain. So, and then markets and customers. Your customers are asking for this and demanding this, and our employees are asking for us to get involved in sustainability as well. So there's both drivers and risks in that conversation. Let's talk about regulations briefly. I told you I've been in this game for about 3 decades now, and I have never seen things move so quickly as they are in this space right now. So a 647% increase since the turn of the millennium on regulations. And I think it's only accelerated in the last couple of years too. So, It started kind of with the UN guiding principles, setting, that's not really regulation, but setting a framework of 31 principles that all of the UN charter nations sort of agreed to. But that then drove some regulatory action, and I will call out just a couple of them here. In the EU, you've got the Corporate Sustainability Reporting Directive and the Corporate Sustainability Due Diligence Directive, two very new ones. In fact, the Due Diligence Directive just went live, if you will, last week. And CSRD sets a framework for how companies need to report all of their risks and what they're doing about that. And CSDDD requires companies to do the due diligence throughout their supply chain and assure that due diligence in their reporting. So it's no longer kind of optional to do sustainability reporting. It's now, well, we're in Vegas, table stakes. You have to do it. And the interesting thing about these regulations is that the way they've written them, if your company participates in the European economy, then these rules apply to your entire global operations. And because they require you to look at your entire supply chain, there will be a trickle-down effect to all of your suppliers, because you're going to need data from them. You're going to need them to get on board and help. So it's hugely impactful and an evolving area. The US is involved as well. You've probably heard of the SEC climate rule. It's currently stayed, so we'll see how that goes. But that requires companies to report their scope 1 and 2 emissions. And then, not to be left out, the states are getting involved. And California has a similar rule. So you've got this landscape that is shifting and changing rapidly, and also quite complex from a regulatory perspective. So what does that mean for your suppliers and that whole value chain? It means you really have to partner with your suppliers and work with them. So building those on those relationships and leveraging your suppliers, understanding where risk is. And it may not be with your highest spend, right? The John Deere example, for example, small company represented some risk. So collaborating with your suppliers and supporting your suppliers on the journey is really important as well. Many of these companies just haven't had to deal with this and don't have the resources or the expertise to dig in, and they're going to have to fairly quickly. And then probably, maybe most importantly, is creating alignment and consistency. So be clear with what your goals are and what your expectations are for your suppliers. And again, 70 to 90% of your footprint is there. So working with them is going to be just really important to your goals. So successful companies in this space will do that. They'll clearly articulate those goals. They'll treat those suppliers as partners and work with them. And then we're going to talk about this a lot, I think, in the panel, but successfully integrating value chain sustainability into into decision making. What does that mean? It means, what is every single person in this room, what is your path, your vision to impacting sustainability performance in your company? And how does that drive the decisions that you make? So sustainability decisions are now essentially a design parameter for what we all do, right? So, okay, I'll leave it at that, because we're going to have an opportunity to do a lot more talking about this. So looking forward to that.
Thank you, Adam. Good job.
Awesome.
Thank you.
Adam, everybody.
Thank you.
Awesome. Well, good morning. Happy almost Friday, ladies and gentlemen. My name is Keshav. I spent about 15 minutes yesterday trying to coach my fellow panelists on how to remember and pronounce my name. So I'll do the same with you. So if you're a millennial, think of the singer, actor, performer Kesha, the lady with the dollar sign, and add a V at the end. And if you're not, then just think of a guy called K who's shoving sustainability to you. Okay. All right, so I live in Orange County, Southern California, and I have about 15 years experience helping implement two of the most confusing things in the industry: digital twin and digital thread. A lot of our customers, that I've worked with, essentially consider digital twin and digital thread to be almost like love. You ask 10 different people what love is, you get 10 different responses. And it's, sustainability and digital twin and their intersections are no different. So let me see if I can demystify some of this. This is the most important slide that I'm going to present to them. I'm just kidding. So let me try and answer 3 key questions. Why digital twin for sustainability? how are some customers actually using digital twin and digital thread technologies today that goes beyond just using modeling and simulation, right? It's an organizational behavior that comes with it. And last but not the least, what are some key sustainability use cases that you can actually start making progress today? I thought I would start with a few actual customer examples because customer stories are much better than me coming up with definitions. So here's one of the customers that we've been working with for the last few years. They've historically been obviously running a lot of modeling and simulation in their research world. They have obviously a lot of mechanical engineers, electronics engineers, electromagnetics engineers, controls engineers who essentially model, simulate, and optimize their individual functions. But their CTO reached out to us and they said, hey, we have all these models. We have a lot of telemetry data that our pilots have essentially gathered with our intelligence, surveillance, reconnaissance systems. And we also have hired a lot of data scientists, but they kind of lack the domain expertise in terms of leveraging, physics-informed AI, if you will. And so they said, can you guys help? And so for this customer, digital twin was essentially an integration of the models that they had built in their research phase, making them efficient, and having the system of systems view, or having a holistic understanding of how a complete system behaves, but then connecting these models with big data coming from inspections, sensors, metrology, meteorology, telemetry, so on and so forth, right? And so you have this complete integration, if you will, between physics and data and everything in between. Here's another example. We have engagements going on with a lot of aerospace OEMs who have tons and tons of legacy data. I'm also looking at you, Erin. Boeing has maybe just a little bit of legacy data. And so the question is, you have a lot of synthetic data, you have a lot of test data, you have a lot of in-service data. How can you essentially make use of it? How can you essentially use that to derive better requirements for both for sustainability, but also for future product development? For instance, there are technologies that are engineering data science focused, that are low code, no code, tailor-built for engineers like you and me, that allow you to essentially extend to your existing legacy data and essentially be able to reduce the order of these models, either through geometric deep learning or machine learning, and essentially use these reduced order models directly on CAD models. You don't even really have to run through simulations. So that's another example of a digital twin, in that it's primarily based on using engineering data science as a focus. Here's another example. This is from a large nuclear customer based out of the UK. They had a center of excellence team internally that have a lot of expertise around computational science, around data science, etc. But they went on a mission to do two things. One, help predict the remaining useful life of a lot of their power plants for their customers. And two, democratize their expertise, not just the technology maturity, but really take sustainability at scale through digital twin, right? And so with this customer, a digital twin was essentially the necessity to listen to what the physical asset is saying or doing, and accordingly provide better guidance in terms of predicting the remaining useful life, coming up with a more predictive maintenance schedule as opposed to a reactive maintenance schedule, and so on and so forth. Why did I show these case studies? Essentially to make a point that digital twin and digital thread, in my view, perhaps I'm biased, is at the heart of sustainability. I think there are really three major benefits to how and why people are using digital twin today for sustainability. One, it reduces CO2 emissions, right from material extraction all the way down to service and maintenance, including being able to predict remaining useful life and extending the life of assets that are currently in operation. Two, it minimizes the amount of physical material and energy that's required. And three, it makes it easier and more efficient for teams and organizations to organize information, but also to mine on that data. And there are multiple different types of use cases for digital twin, from design to manufacturing to operations. And we'll go through some of this over the next hour or so, right? But if I take a step back and if I look at the sustainability spectrum in terms of how the industry has really embraced the sustainability practice. So on the y-axis, I have value. The value could be business value or product value. The value can also be automating product and business decisions. And on the x-axis, I have time. Historically, a lot of the aerospace and defense OEMs have used technologies such as topology optimization, have experimented with sustainable aviation fuels, with materials, so on and so forth. But as we are heading towards a more connected, smarter era, where we are seeing maximum value being added is what I call the convergence of computational science simulation, compute, both software and hardware compute, along with big data, right? So it's the convergence between simulation, high-performance computing, and AI that's really providing newer and greater experiences around sustainability for our customers, right? And so digital twin is obviously part of it, but there are other attributes to digital twin as well. So I've been using digital twin all this while. And by the way, I also have a digital twin song for you. That was a surprise. I was telling the panel that I have a surprise. If you hold on for a few more minutes, maybe once we're done with intros, I will sing that song for you. But let me first define what a digital twin is. So in our experience, again, working with hundreds of customers, a digital twin is a continuously evolving dynamic model of systems. These models or these systems can be based on a physical process or a biological process or a business process, talking about supply chain use cases. But these are not just grounded in statistics, it's also grounded in physics, wherein you're assimilating data coming from inspections, sensors, metrology, meteorology, so on and so forth. And there are really two sides to the coin. There is the design end of the digital twin, and then there is the deployment end of the digital twin. So being able to use modeling and simulation, and I think the next two presenters are going to highlight some of that, requires you to have systems thinking, requires you to go beyond just simulating your individual domain. Look at interactions between multiple domains, and by extension, also leverage things like reduced order modeling and so on and so forth. And on the deployment side, you have things like being able to do anomaly detection, condition-based monitoring, and be able to come up with more accurate predictive maintenance schedules. There are tools out there today that provide either a more simulation-centric digital twin experience or a compute-centric experience or an analytics-centric experience. But like I mentioned earlier, it's really the convergence or the integration between simulation, compute, and data, which is where the magic really lies. And so we have this convergent set of technologies for you to access. But modeling without systems engineering is a big no. In fact, Tim is going to talk a little bit about MBSE. So you also need a traceable thread for all the different types of modeling that you enable. And so there are, once again, multiple different interpretations of that. But in our experience, working with real customers, a digital thread essentially allows you to link information across your entire system lifecycle through a common data model or through a common data architecture, right? And once again, there are multiple technology enablers for this, from model-based systems engineering on the left side, if you will, of the product development, all the way to knowledge graphs for doing semantics, and ontology, all the way to the right? And so there are multiple enablers. I see that my ticker is going up. My time is almost coming to an end. When you combine the two together, when you combine modeling and systems engineering together, you essentially have what I call a single source of truth or a single pane of glass view for digital engineering, right? So I know that it's easy to show slides. It's maybe easy to show examples, but I also want you to remember something from my presentation. So a play of words here. Sustainability. So there are about 5 things that I want you to remember. Maybe I'll quiz you towards the end if you still stick around after I sing. So sustainability, SU, supply chain and converging data through supply chain, everything that Adam spoke about, and being able to innovate with legacy data, key for sustainability, right? And we have a number of aerospace customers who have been looking at knowledge graphs, for instance, as a key enabler for the supply chain integration. The semantic platform to being able to connect data streams from requirements all the way down to your in-service life cycle stage is going to be extremely key to essentially doing faster root cause analysis. I'm completely out of time. Do I have a minute? One more minute? Okay. Sorry, panelists. Sorry, everyone. ST, systems thinking. Systems thinking with digital twin. So being able to integrate models, domain knowledge, compute, data, right? And there are a number of examples, from NASA to several other energy companies. I'm going to skip through this because Eden or someone else would just kick me out of the panel. I don't want to do that. Sustainability has AI in it already. So AI-powered engineering, AI-powered manufacturing, AI-powered operations are all key. And like I showed you earlier, you don't really have to wait to hire data scientists to really leverage AI. You can be a mechanical engineer and still use AI in your day-to-day function, right? And you can also take it past just the physics-based. You can also do data-driven workflows through no-code, low-code architecture. N for sustainability. New material selection and having consistent material data, right? The next two presenters are going to cover this, so I'm not going to go through this in detail, but I'll make maybe a copy of these slides available to you for future reference. But if you have all these things, and if you don't have the ability, the organizational ability, or the behavior psychology, if you will, mapped out to these modeling capabilities, then it's as good as not having a digital twin practice. And so there are a number of key enablers to do this. One is model-based systems engineering. The other is knowledge graphs. Stephen Algetz, my colleague, I actually see him, so he's here. Oh, by the way, we have a booth close to the AIAA hub if you want to come talk to us. A lot of the companies that we have continued to work with, they call themselves the product, the Microsoft Office product development organization. In that, between different departments, the primary mode of communication and collaboration happens through informal documents. I think Tim is going to highlight about that shortly. And so you can essentially use model-based systems engineering to use a common model as the framework of collaboration. So to wrap it all up, let's see how many people remember. So what does SU stand for? Anyone? Okay. Supply chain, there you go, supply chain data convergence. ST, systems thinking with digital twin, excellent. You're a wonderful audience. What does AI stand for? AI, okay, AI-powered engineering, manufacturing, and operations. N, any guesses? New materials, yeah, fantastic, wow. And last but not the least, ability with MBSE and knowledge graphs. That's all for now. I'll be back. Thank you very much.
All right. Thank you, Keshav. I'll introduce myself. I'm Tim Kirk. I lead our marketing strategy and government relations for Toray. Toray is for those of you that don't know, Toray is a global chemical company, and I represent our carbon fiber and composites division here in the US. Principal to the discussion about sustainability, I'll talk about aviation and next generation aircraft, but also linked to that, although not directly, is our large practice in next generation materials, as well as alternative fuels for our ground transportation system. So, I was surprised when I was asked to join the panel, and I'd like to thank AIAA for inviting me, but I was surprised with the convergence of thought between each of our perspectives. I am from the raw materials space, so a little bit unique in terms of the enabling technologies that we bring to bear for aerospace and sustainably building the next generation of aircraft. I think all of my colleagues across the raw material companies have this kind of a chart, but I think for us anyway, thinking about sustainability and the new definition of sustainability being more holistic, model-based, and long-term, we have to think about where we are today and where we came from. So if you think back many decades into the age of aerospace, new alloys were the principal driver for material requirements in vehicle designs. Those evolved as a result of the space age to new exotic materials and ablatives for things like re-entry vehicles. We moved into new aluminum alloys in the 70s and 80s for things like supersonic transport and next generation commercial transport, principally the age of the 757 and 767 and the rise of Airbus with the A300 and the A310. In the 90s and early 2000s, into the age of composites, where OEMs began to think about using composite materials and lightweight solutions as part of a selection of technologies that would reduce weight and improve efficiency of particularly twin-aisle aircraft first. These were driven by first the 787, and then by Boeing, and then later the A350 by Airbus. But I think the thing to remember there is that this change in materials technology enabled new value for the OEMs, but also new value for the airline operators in terms of things like range and maintenance cost, cabin comforts for those of you that have flown on these aircraft, and reduced fuel burn and improved economics for the airline. And that brings us to today, where we have a blend of high performance, high rate, and affordability. And I mentioned affordability because it is key to sustainability. When you think about sustainability for aerospace, at least from our perspective, we look at it in two horizons. The first horizon would be, what can we do today? And if you look at the technology suite available today, and you extrapolate that to what we could do, there's a fairly sizable gap, meaning that how could we leverage today's technology to improve the sustainability of the air transport system as a whole, not just from a design perspective, but the entire system. The reason that gap exists is principally because of economics and affordability, not because of some technological gap. So how do we scale sustainable aviation fuel is one example of a driver of that gap between technology available today and where we could be as an industry. And then the second horizon is what is possible with this continuous iteration of technology that will get us to a new horizon for things like new vehicle architecture, new design philosophies, and new materials. So I throw this slide, and I wanted to start with it because it's important for us to understand where we are today, where we came from, to really think about how we as an industry can move forward to a sustainable future. And it's a fundamental change in mindset. We are, from a raw materials perspective, we look at how customers define and determine value. And it is not principally driven by material performance alone. So while materials remain critical in these emerging markets, how companies create sustainable value is becoming, as was mentioned earlier, more of a table stake. It is more of a competitive factor in the markets that we serve. So for Toray anyway, and for many companies, many global companies, we have four perspectives of the world that we envision by 2050. And you can see these here. I will not go through them, but they are aligned with being a responsible corporate citizen, but also thinking about things like the UN 17 and a more holistic view of sustainability that has really evolved since maybe as early as 10 years ago, when we were really looking at the environmental burden and how we could reduce greenhouse gas emissions. That is still a critical part of the environmental portion of ESG, but it is now more holistically defined, as was mentioned by my earlier colleagues, in things like CSRD in the European Union, which is a plethora of a broad base of reporting metrics that measure sustainability across the spectrum. Kashab mentioned the digital part of sustainability and how important it is. We view materials being a part of a dynamic production system. If the production system isn't efficient, then the production system isn't sustainable. So again, think of where we are today and where we could be with the technology available today. The principal reason that gap exists is economic, not technological. So these are going to be enabled by digital, and model-based systems engineering we see as the kind of centerpiece of being able to incorporate the materials pedigree, which is earlier what many thought of when they thought of digital twin. They thought of just the quality record or the materials pedigree. That's an important part, but it doesn't provide the value of the systems engineering side of MBSE. Automation, quality systems, lifecycle management, adaptive tooling and modeling simulation, rounding out this suite of processes that are all central to being able to get to this kind of end spot for model-based systems engineering, enabling a digital architecture, having a precise and accurate digital representation of the production system. And for us, sustainability is a centerpiece of markets. We in Toray, we view sustainability as the most important global issue of the 21st century. And we look internally at transportation systems. So the materials that we provide offer lightweighting opportunities and additional value for the customers that we support. Supporting renewable generation such as wind and solar. This is the industrial side of our business that we're very proud of. And then responsible manufacturing internally and reducing our net operations emissions to net zero by 2050. Those are our internal actions, but also, as I mentioned earlier, society is focused on a more holistic set of defining sustainability. I'll be interested to move through the questions in the panel and think more broadly about how we as an industry can react and move us forward together. So materials must enable sustainability, but business partners through the supply chain must also demonstrate sustainability. It is now a table stake, and we view it as a competitive element of the markets that we support. So thank you very much, and I'll turn it over. Thank you.
Erin just reminded me to introduce myself. I asked her to do that seriously because I am notorious for getting up and talking and not doing that. So thank you, Erin. So I'm Ed Glaskin. I'm NASA's Senior Technologist for Computational Materials. I reside at NASA Langley. You'll see a second name on the authors of this presentation, Michael Gorlick. Michael is my partner in this quest to insert modeling and simulation in the qual insert process. Michael is the FAA Chief Scientist for durability or fatigue and damage tolerance, sorry. And so we often do this as a tag team, but I took some slides out of kind of our standard talk and we'll adapt them to sustainability. I think a lot of what we're doing here towards the insertion of modeling and simulation in really material qualification is very adjacent, I'll say, to the quest for sustainability. Right? The better we understand materials, their processing, their performance, the better, I think, the more capable we are of understanding things like material substitution, about things like high performance structures and components needed for things like electric power, electric propulsion, those kinds of things. So I'm going to go through this talk, and we'll talk about sustainability a bit as we go through it. And so this is one of our value propositions here, and that is that additively manufactured, and we focus a lot on AM, additively manufactured flight hardware is becoming increasingly complex. Right? In the upper right, one of my favorite images, this is from some colleagues at JPL, where they looked at transitioning between titanium and a stainless alloy and doing it without a sharp interface. Right? That gives them certain multifunctionality, some functional aspects of the material as well as the structural ones without having that interface. Right? Nature really picks on interfaces. And so this is kind of a way of getting around that. But I'll say they designed this material, and it was designed, again, for a particular application. How are you going to qualify this, right? The traditional method of qualification is around building what are often termed witness coupons. They may not really be indicative of a particular feature in a part, but they are in some sense representative, or just round bar fatigue test specimens, let's say, that kind of thing. Here I have a material that every location through the thickness of this is different than every other location, right? The microstructure is different, the defects are different, certainly the performance is different. And I need to say that this is a qualified material. And so where we're going with this whole insertion of modeling and simulation, yeah, it is, I think, really useful. When I talk to chief engineers from the OEMs, and I do talk to chief engineers from the OEMs, they always come down to the bottom line. It's always about, how much time does it take to qualify a new material? How much does it cost? And that is really kind of the underlying issue around why there are so many great conceptual materials that are never used in flight. And so that kind of addresses that. The other side of it is what you see in that figure. And so here we're talking about a material that I think in a large sense can't really be qualified using conventional methods without taking a really big knockdown. And not aeronautics, but as we were talking yesterday, NASA has a quest for manufacturing in space. How are we going to do that, right? How are we going to make a material in space, even around welding, which is kind of the first quest? How do we do that without making a jillion, well, many anyway, coupons, sending them back to Earth, or in an absurd sense, sending the testing equipment into orbit? So I think a lot of this is we need to get smarter. And when we think about sustainability and we think about things like material substitution, right? Greener materials, alloying elements, how do we understand that performance? How do we understand how well those materials can be processed, short of just making a bunch of things and testing them? Well, I'll show you on another figure an electric motor that was additively manufactured. Right? It really reduces the scrap. It allows for some really complex designs with many fewer steps additive manufacturing does. But again, I need to be able to qualify that. Excuse me. And so kind of in conjunction with the new, the push for these more complex parts is the push for their use in safety-critical, fatigue-critical applications. And so my organization, NASA, my colleagues down at NASA Marshall, have suppliers showing up saying, we want to fly this. How do we do that? How do we do that and not have a bad day, as the saying goes in the agency? The FAA is even more conservative. Right? They do not want an aircraft going down because of some failure, because of a part that was used when let's say its performance wasn't well enough understood. And the same for the DoD and others. And so I postulate that the current paradigm is not really extensible. It is very time-consuming, it is very costly. It doesn't enable a lot of the things we've been talking about. And so, again, this is a NASA thing, but we post-process materials to get them to look like something we know how to qualify. And so we lose a lot of the advantages of those materials. So the goal here is to really open up that opportunity space. And I think because what we're doing is so adjacent to the sustainability offering that there's a lot of opportunity here to bring sustainability into the sort of paradigm that we're advocating. And so I'm going to talk a little bit about a group, and so I'm going to get a little bit away from maybe the vision, the technical, to kind of how we operate, how we're doing this. And so when Michael Gorlick and I, Michael from the FAA, we're kind of envisioning what this looked like, we realized we need to bring various segments of the community together, different perspectives, all with a common goal. And so those goals are coordinating investments, right? My organization does work in this area. I lead a group that I'll talk about it towards the end of this. In this area, DARPA just stood up a new project, a new program around this type of a computational materials informed qualification. There's a lot of work like this, bits and pieces. And so we're trying to coordinate that. We're also trying to increase acceptance. Right? We don't want just another journal paper. Of course, that is a currency where I live. So, but it's not just about journal papers, right? It's really about getting these methods accepted. And so, again, with my native guide, Dr. Gorlick, I think we have a real chance of doing that. And a lot of dialogue. I'll show you the organization on this slide. And so a lot of government agencies, as you might expect, mine, the FAA, the DOD, the DOE, NIST. Some universities, there's some really good academics out there that really get it. They really understand how to be impactful. And we have several of those guys. But the key to this is really the industry. So these are the folks who understand their problems, who understand the value proposition better than I do in a lot of ways, and are able to then guide us on this path. And so I see the timer. I hope that's not correct because it says I have just over 2 minutes. And so I will pick this up a bit. And so the steering group that we have is really organized by TRL. So low TRL, high TRL, and most importantly, that bridge in between, the valley of death. And so we are actually rolling out a roadmap in this area at the MS&T conference in Pittsburgh in a couple of months. So key drivers for industry, right? I said time, cost. Nothing matters if the company goes out of business. So that is a big deal for them. Improved products, the ability to realize new designs, the graded compositions like I was talking about before. For the government, it's a lot of the same kind of things, but also understanding where to invest. And so that is something that we are really trying to lay out in a way that doesn't get us in trouble. And then finally, for academia, it's a lot of those things. It's about research, what's coming down the road, but it's also about training the next generation of workforce. And I think in the sustainability world, as in the world that I mostly live in, durability, you got to have people who really get it, who really understand the problem, and can set the path forward and actually work out the actions that we envision. So this is my next to last slide. It is the group that I lead for NASA, very synergistic with the steering group that I spoke about, really about understanding process, structure, property, and performance relationships. I don't get to see how company X qualifies its material, certifies it. That's between them and the FAA. So I'm not read into any of that. So what we are doing is trying to develop a capability here that uses modeling and simulation, uses data science. There's a little bit of machine learning in there. There's in situ monitoring. And developing this new paradigm where we get a lot smarter about this process of taking materials from the lab to flying them. And so that is generally the goal. I just want to point out in the upper right of that figure is an additively manufactured electric motor for aircraft. And so this was a project that the CAS project, Convergent Aeronautical Solutions project in AR&D funded a few years ago. And I think it's a real good example of where this kind of work really buys its way on. And so that's all I have for you. My email address is there, and if you'd rather hear it from the FAA, Michael's is there as well. So thank you all.
So So thank you, panelists, for getting us started. I think now we'd like to hand over to Jason from SharpCloud, who's going to just give us a little bit of a tutorial on the software product that his company provides and how we're going to try to weave that into a discussion. So whether you knew it or not, you all are kind of part of call it a social experiment, right? You've all sat in on a lot of panel sessions, a lot of technical sessions over the last week, and now on Thursday of the week, there might be a sameness that you're starting to feel. So what we're trying to do here is shake it up a little bit and find ways to connect dots real time within the panel and really include you and pull you, draw you more into the discussion. So with that, Jason, please bring us up to speed.
Absolutely. So here in a moment, we're going to have my colleague, Daniel, actually put SharpCloud up on the main screen. So we can see this is starting to populate now. So just to introduce myself, my name is Jason Lefevre. I lead our US solutions for SharpCloud. And as Atherton said, we're going to try to do something a little new here. So at SharpCloud, our goal as a portfolio management software is to help bring disparate data together to allow organizations and their users to make more informed decisions. And the first part of that is understanding that landscape. What do those connections look like? And then as we go through a journey, we start to explore those connections and actually plan and roadmap. And the reason that's so critical is because of some of the things that the panel's talking up here today. There's legislative initiatives and regulations coming out. And if you are planning a product launch based on technology that needs to go in that product to make it more sustainable, whatever it may be, all of that has to be aligned so that way if there is any misalignment, you're aware and you can take immediate action. So as we started to work through this with the panel, if we look at the strategic landscape, what we've identified are some areas of focus. So I'm not going to talk about all of the different items on the view here, because you'll hear that as the panel goes on. But what we'll start to see is we have some impacts, and we can start to continue to build this out. So from impacts, we can start to bring in other categories of data. So maybe we're looking at regulatory drivers that Adam talked about. We can continue to bring this out and look at maybe the risks and challenges that are impacting the industry. We can start to look at opportunities that may come up, and then start to see some key themes that we're focusing on within the industry, and then also those innovations that we're working on, such as digital twin, which we've heard a little bit about today so far. And really where the power of SharpCloud comes is we hear all these panelists talking about these as an individual idea, but if we actually turn on what we call relationships in SharpCloud, we can see this complex web, and it's complex and messy because that's the way the world works. These organizations have a lot of moving parts that they need to connect. And the beauty of this is as we start to have the conversation today and we start hearing the panelists talk about certain challenges, we'll actually be able to narrow down the focus to see how the industries and expertise areas that they represent all actually come together. So if we were just, for example, look at maybe the risk and challenge of materials compliance, what we can do is click on this and actually hide all the noise and tell a really succinct story where we can see that materials compliance actually has direct relations to some of those regulatory drivers that we heard from. We can see it starts going into advanced materials and advanced manufacturing, some themes that we talked about, and ways that we can start to overcome that with the innovations that are already in the industry and innovations that may be coming up tomorrow and in the near future. So as the panelists start to have these discussions, what we're going to do is as they mention a challenge or an opportunity, we're going to try to make this a little interactive where we'll click on this so we can see actually how integrated all of this actually is within the conversation. And if there's a new innovation that they start talking about or a new challenge, actually draw those relationships live so we can see how complex this really becomes and how intertwined everyone actually is when it comes to overcoming and making sure that we're leading the most sustainable future. Thank you.
That's terrific. So thank you, Jason, for giving us a quick tour, and Daniel, thanks for driving. So this is honestly a bit of an unscripted experiment. I think we're all curious when we, at the end of the next hour that we spend together, what are we going to be able to learn? I mean, I think this view kind of shows us something that we all inherently know about, not just this type of problem, but many of the problems you all face. They're complex. There's a lot of connective tissue, a lot of things that tie together. There's many layers to the problems. The question is, what kind of insights can we gain out of that? So I would say let's maybe dive in and find out. So I'm going to tee up the first of four, I'll call them planned questions that we have, but I already see that we're starting to see really good questions come in from you all. So please, as you think of new things you'd like to kind of insert into the conversation, please make sure to post them and we'll work through them here over the next hour. But as far as a first intro question, so what major challenges face widespread growth of sustainability? Are there technical or integration gaps that need to be addressed?
I can take a swing at that. When I think about that, I think about it, you saw the diagram, right? There's lots of challenges and arrows, as you brought up, and connections, but two kind of themes come up for me, which is alignment for agility and data to drive systems thinking. And we heard a lot about data, so we'll have a robust conversation about that, I think. But what do I mean by alignment for agility? It goes back to what I was talking about in my introduction about ensuring that we understand where we're headed and are able to then communicate that throughout the organization so that all of the moving parts in our very large organizations, and if you include the supply chain, it gets to be a lot of people doing a lot of things, are aligned, and we're moving towards those goals. And so clearly stating what your goals are, understanding the shifting regulatory landscape we talked about. Like I said, that one regulation, CS-DDD, was just fully promulgated last week. So things are moving very dynamically in this space, and we have to stay on top of that. And I think that's why the second piece is so important, is the data to understand where we are on that journey. Where are we with our materials that are available to us, and how can we make better design selections at the design engineer level and at the sourcing level and at the research level to solve problems, right? We have to know what problem is that we're trying to solve for, which sounds kind of familiar, right? I mean, this is how we design things. So it's just another design parameter, but we have to have the data on where our suppliers are with all of their performance, what's available out there at the right places in the organization to make the informed decisions, to have that alignment, to be agile and address this problem. So, and I think about what you said with digital twin. Maybe dive in on some of that.
Sure, I'd be happy to. So, when it comes to challenges, I think there are a few that come to mind. The first challenge is maybe I'll call it vertical silos. Erin spoke about the necessity to have systems thinking. I think a lot of us, I'm a mechanical engineer by education, so when I first joined the industry, I really just cared about my domain in terms of using simulation, modeling and simulation, but also to be able to simulate and optimize my individual function. But the products that we sell, that our customers use, are primarily cyber-physical in nature. And so how do you embrace systems thinking from the concept stage, or right from requirements, as opposed to having to wait until you have a physical product and then you start looking at how the entire system functions, right? So there are these vertical silos in organizations where people essentially have a piecemeal understanding of how an entire system works, as opposed to a holistic understanding of how a complete system functions. An extension to it would be what I call horizontal silos. So as you go from stakeholder analysis or voice of customer analysis all the way down through, having your requirements architecture, your physical architecture, your logical, etc., and up the testing chain and the integration and the mass production, there are multiple types of data sets that get generated, multiple types of models, different people, different functional areas that all come together. But to what Tim mentioned also in his presentation, the primary mode with which we all communicate and collaborate to track the performance, cost, and mass is through PowerPoint documents or Excel spreadsheets. And so the more informal the communication is, I feel that there's going to be more and more silos and more design errors that you would get at the fag end or the later end of the spectrum. And so that's another key challenge. But the last challenge I would say has nothing to do with technology, but has everything to do with behavior psychology. I think understanding organizational behavior and providing tools and methods that can actually empathize with the user community is going to be key to drive some of these initiatives forward. I'll give you an example. So I worked with a large semiconductor capital equipment manufacturing company. They're based in the Bay Area. They have a center of excellence team that primarily focuses on leveraging all kinds of computational science and data science and all these things to support their clients like Intel and TSMC, et cetera, who buy their products. They realized that they really needed to scale their operations because they cannot always rely on 10 or 15 people within an organization to know everything. And so how do you empower non-expert users to also run some of these simulations without them really realizing that they're actually doing it? I think that shift in narrative, I think, is also key, and that's another challenge that continues to prevail. What do you think, Tim?
I might add one dimension, or another thought dimension, and that is, I think a theme that we've seen develop over the last few years especially is this notion of iteration, where the realization is that we can't make perfection the enemy of the possible. I'll go out on a limb and say, a hydrogen-powered commercial airliner by 2030 is probably not achievable. Not achievable technologically, but also not achievable with the infrastructure investments required. So I think that's why when you look at kind of the OEM and industry mentality today, it's about making measurable improvements in the most efficient way possible. Meaning that, as I spoke, most of the gaps between the technology available today and where we could be are economically driven, not technologically driven. So that's why tools like SharpCloud and other software that allow us to look at a problem and not just diagnose it, but able to dissect it into manageable pieces are really important, because there's a lot of lines on the relationship map on the SharpCloud diagram, but I think we know that most of those relationships are not linear. Right. And there are time delays between action and reaction. And so we as an industry need to provide ourselves as well as leadership with the tools to be able to predict reasonable outcomes to kind of support this iteration of doing as much as we can, but doing it in a way that's responsible and can put us on a path to where we need to be.
Yeah, good. Yes, sir.
Ed?
Thanks. I was waiting.
Dr. Ed, please, your turn, sir.
So I view the world through the lens of when is something going to fail. Right? That is my background. I'm a crack grower by trade. And I often say that it is not as much, in a lot of cases, the vehicle that rolls off the assembly line as the vehicle that is retired. And that entire life cycle cost, life cycle performance. And I think that sustainability is another element to that. We can't look at anything in isolation. We have to look at the entire system, the entire life cycle. So everything from sourcing materials through the performance of that vehicle from a fuel burn standpoint or whatever your metric is, all the way through to what are we going to do when we retire it? How are we going to scrap it? And that is a multi-objective optimization problem, right? That kind of at its fundamental level. So being able to understand that and having the simulation capabilities, the AI data science kind of capabilities needed to map and kind of accumulate those points all the way across, I think is a really big, need to be able to make informed decisions that check a lot of boxes, check the other ilities as well, right? Durability being my favorite, sustainability obviously, but also another one that we have to consider, and it's kind of a dirty word, profitability. These companies have to be able to do what we're talking about here in such a way that they keep their shareholders happy, or they're not going to be doing it for long. So it's kind of that big picture that I think we need to take with sustainability as yet another element to the overall picture for vehicles. Jason.
Great. Well, thank you all for those answers, and I agree. I think that life cycle view and having tools and the model base, which I think we called out on our Sharp Cloud earlier, is that digital twin is a key technology to help us be able to do all these things within sustainability. I want to ask you, what are the trends that you are really seeing now within your scope of work around sustainability and how it's impacting the work you do? I know a lot of you talked about it with your slides, but anything you want to add to that?
Yeah, I did talk about this a bit on the slides, but I'm seeing really an acceleration of focus on this. And I do think that it's being driven not only by the emerging regulations that are definitely sort of solidifying it, but by the demands of other stakeholders as well. And so, I think that's one of the biggest things that really should come out of this discussion is that wherever you sit in your company or in your profession, this is coming, and it's coming quickly. And so you really need to understand what your line of sight is to what your impact will be on the goals that your company is setting and how you can contribute. And so, we all need to learn and understand what that looks like. And, that education will help you with executing on that. So my thoughts on that.
And I think those regulations pieces, Ed mentioned profitability, but those policies and regulations are going to greatly impact that profitability. Yes. And so that calculation may be changing as we move forward.
Yeah.
We have to consider.
Very dynamic.
Yep.
One theme I see that, one theme emerging that is really post-pandemic, but I think supportive of what's required for sustainability is new ways, I may call them uncomfortable ways of collaboration. Because regardless of where you are in the tiers of the supply chain, we all live in a competitive environment and we have to return profitability to the shareholders. But I think there are certain elements of the solution set, if you want to call it that, for sustainability will require industry to collaborate, especially horizontally. Mm-hmm. We as raw material suppliers with other raw material suppliers as an industry perspective on actions for sustainability. We're going to do what we do as to create value for our customer, and that's competitive to us. But there's also needs to be more of an industry perspective on things we can do together. End of life, life cycle, recyclability, all of that, I think are going to take a broader voice, a broader industry voice, probably horizontally and in some cases also vertically through the supply chain.
Great. Daniel, actually, I think we can add that as a trend, industry collaboration onto that. Great. Thank you.
Awesome. Well, since we're talking about trends, maybe it's now time for me to set the trend. And
It's the song.
so have you guys heard of, I'll answer the question, but before that, a quick song break, y'all. Okay. Have you guys heard of James Blunt's You're Beautiful? Some of you? Yeah? Okay, great. So, you know how the song goes, right? My life is brilliant, my love is pure. So I've sort of modified the lyrics to actually include the definition of digital twin that I presented. So here goes. You ready, Dr. Ed? All right.
Absolutely, sir.
My life is brilliant, my love is pure. I saw a model, of that I'm sure. She smiled at me at my computer. She was assimilating data. Oh, I won't lose no sleep on that, because I've got a plan. Your digital twin, your digital twin, your digital twin, it's true. I saw your predictions in a crowded fleet, and I don't know what to do. And that's why we're all here for you. Thank you, I hope.
did so well in Las Vegas.
Thank you, thank you. And people are still sitting down. You know, I'm so happy. I'm so happy no one has left.
Starting a residency soon?
Absolutely, yes, yes, something like that.
Johnny Osmond is out, Keshav is in.
But talking about trends, going back, serious mode again. I have some dad jokes too. If you want to stick around, I have a few dad jokes later on. So, a few trends come to mind. Let me ask you a question. How many of you here have used ChatGPT? Awesome, awesome. So me too. So if you actually ask ChatGPT to generate an image of 8 elephants, or rather 7 elephants sitting on a bench. Has anyone tried this experiment? You should really, you have, okay. So no, you have not. So you should go back and try it. So ask ChatGPT to generate an image of exactly 7 elephants sitting on a bench. What it would give you is a very nice image of elephants sitting on a bench, except that there would be 8 elephants and not 7. Okay. The reason for that is hallucination. So a lot of these Gen AI models tend to hallucinate and tend to be more probabilistic in their predictions. So one of the major trends that I'm seeing in the industry is leveraging knowledge graphs as a semantic layer to connect through all different types of data sources within an enterprise. From requirements to PLM, both the mechanical and the electronic ECAD systems, all the way down to your CAE models, your computer-aided engineering models, to manufacturing data, to your in-service data, so that a lot of these predictions can be less and less and less hallucinating. Right? That's one big trend. Another trend that I see is that more and more mechanical engineers, power electronics engineers, controls engineers, thermal engineers, they're leveraging data science without them actually realizing that they are. So there is this whole, if you will, workflows that have been enabled within our own computational science modeling and simulation environments that allow you to take your legacy data or your existing whatever training data and quickly train up neural networks so that you can directly use that on top of CAD models as opposed to having to always start with a mesh and run the analysis and so on and so forth. And the last trend that I see is that systems engineering as a practice historically has been done by systems engineers using SysML as the backbone. And it's a phenomenal practice. In fact, I'm SysML certified myself. But product development engineers don't really, we spoke about complexity. Product development engineers don't really see the value of doing systems engineering because, number one, it seems more idealistic to use these really organized models. And so there has been a trend towards making SysML compliant tools or systems engineering tools more product development friendly. Now, going back to my user experience challenge that I spoke about. That's what I think.
That's great. Thank you.
Thoughts?
Ed, you talked about manufacturing in space. I know I scared you all talking about climate adaptation earlier in this week, but do you think that your modeling and simulations has the ability to support that?
Modeling and simulation, I think in a lot of ways, modeling and simulation is the only way to support that because of cost. Just cost and logistics and complexity. I kind of paint this farcical picture of making something in space and then sending up an MTS load frame, a hydraulic pump, a barrel of hydraulic fluid, and a really long extension cord so that we can run the tests we need to do to qualify the material. And so if we don't get smarter about these kinds of things, I think we're going to run into certain challenges that really can't be overcome using conventional means. What you heard me talk about for my 10 minutes or however long I went is about time and cost, right, for the aeronautics industry around conventional materials, conventional processes. I want to change something. I have to go back through. America Makes has this Delta Qual program where they talk about incremental changes and that incremental, what's needed to deal with the qualification of something that's slightly different. But if I want to make radical changes, whether it be on Earth terrestrially or in orbit, I think my understanding, I have to really up my game. I have to increase my understanding substantially. It's not just about generating reams of data, of fatigue data. It's about understanding all those relationships. Why a crack, in my world, a crack starts at location X, but not in location Y. Right? What are the differences in the microstructure that cause that? And what are the differences in the processing that cause those differences in the microstructure? It goes back to when I talk about uncertainty quantified process structure property performance relationships. That is really the currency of what we do. And so it really, in a word, it's understanding. Thank you.
Anyone else before we go to the next question? Okay, Atherton, to you.
Yeah, so I'm thinking maybe because we have so many good questions coming in, we maybe pivot to what our audience has in mind. We'll start with one that maybe is a little bit provocative, but it's also, in fairness, it's also the same question we were debating ourselves yesterday as we were prepping for the panel, or very similar. So the question is, and it's actually the top vote-getting question at this point as well. Society calls for sustainability. However, once it comes to cost, things get tricky. Everyone wants cheap tickets, but operators also need their profit. New technologies such as SAF will inevitably lead to increase in cost. How can this be resolved? So I would start, maybe I just start with kind of a broader response, that one of the things that I'm learning more and more about, and maybe not everyone in the audience is aware of, is that there have been some very aggressive goals that have been set for the 2030 timeframe. Particularly in Europe, that there are some nations that are going to start imposing fines and tariffs if you can't demonstrate, if you will, a sustainable chain of custody of how something was made or how something's operating or level of emissions. So there's already in place, there's a ball rolling down a hill that is coming toward us. It's only 5 or 6 years away, that I would say is punitive in nature, in that if we don't do it, if our companies don't do it, they're either not going to be able to do business or they're not going to be competitive doing business in some parts of the world. That said, that doesn't feel to me like a great answer, because it is kind of a punitive approach. So maybe turn it over to the panel to think about, well, what are other productive ways or non-punitive reasons that this all kind of tick and tie together? Thoughts?
Yeah, I'd jump in to build on your thought on policy, right? All policy doesn't have to be punitive either, right? So there's things that can be done to close some of those gaps, to incentivize research, incentivize changes in how we use aerospace products, and how our end customers use those. So, and we saw some of that with the Inflation Reduction Act here in the U.S. with subsidies for developments of technologies where today, without that, economically, it just wouldn't go, right? So, it's not a perfect answer, and I do think that is the challenge, is how do we take this step forward and do it economically? But, there's been a lot of talk throughout the conference in the last couple of days about this being the new kind of space race, and what did we do with the space race? Kennedy kind of put a big, hairy, audacious goal in the ground, right? And said, we're going to put somebody on the moon in the next 10 years. And I don't think any of us here know exactly how we're going to get to the goals that have been set. But we all have a role to play in figuring that out, and then finding ways with policy to close some of those gaps and incentivize that. But, it's going to take a full court press, right? So.
Yeah, on the policy front, two things. One is incentives and investments for research and development, which you pointed out, many of those in the Inflation Reduction Act. But the other is incentives to close the gap from startup to scale production, so that costly ramp-up phase to where you're not maximizing economies of scale. I think we have to figure out a way to that, because managing it through NPV and IRR is not going to get us to where we need to be. Because those all focus on the value today, where we're really looking at the value in the future.
So it feels like maybe some metrics that we can use to kind of capture that future value, that license to operate piece of the sustainability piece, because it's not a today problem, but it is a tomorrow problem and a sustaining our business problem.
But yeah, and I would go back to layer in modeling and simulation, not just for design, but for economics, because maybe our traditional economic or fiduciary tools aren't, they are linearly developed, and maybe they're not sufficient to be able to articulate what the true cost, the 5-year, 10-year, 20-year cost is of inaction today. I don't know that we have that fidelity quite yet, but the modeling and simulation that we think about for design, those same kinds of philosophies in development could also be applied to our financial tools that we use for decision making.
For modeling costs, I mean, what are some components do you think are important to enable this practice?
Yeah, it's kind of redefining opportunity cost.
Yeah.
It's an interesting point of view. Yeah.
Can we add that to the technology lane of our cloud, the sustainability value?
I think one of the places our discussions around this topic went when we were prepping yesterday was, if you take a step back and think about, well, what's the end goal of sustainability? I mean, in the end result, one of the end results is more efficient systems, more efficient products, things that are more energy efficient, more cost efficient to produce, right? So there is an end goal that over time will offset the non-recurring. So you think about something like our current modern high bypass turbofans, right? Eye-wateringly efficient, orders of magnitude more efficient than previous generations, but it took upfront investment of billions of dollars to get that. But there's no airline in the world that wouldn't want those engines on their airplanes because they know over time they're going to make it back. There's a value proposition that has to be longer than 1 year, 2 years, 3 years. This is the long game, I think, and being able to evolve those designs more efficiently, more quickly, to the point of modeling and simulation, is one of the things that's going to allow us to more quickly accelerate that process as well.
Yeah, by definition, the discounting future cash flows to current value is not going to get you where you need to be, right? A 10% discount rate won't work.
Well, so another interesting question, kind of a pivot to a different area that really hits at the heart of kind of the subject matter expertise of some of our panel members. The production of carbon fibers is extremely energy intensive. How can net zero manufacturing be achieved? I'll maybe tee this one up as well. One of the things that I've really kind of wrapping my head around is how long the chain of custody of sustainability is, right? And it's not just the energy that goes into the thing. It's, well, where did the energy come from? So, for instance, I'm based out of a facility in Palmdale, California, and it happens to be the home of the largest privately owned solar farm in the state of California. It produces 2/3 of the energy that we use for our entire manufacturing facility, and that is something that benefits all operations that take place at that facility, right? Whatever we build, whatever machines we run, whatever computers we have on, they all benefit from that, if you will, that trickle-down effect, right? So at a macro scale, it can start with, well, where did the energy come from in the first place that went into the process? And if you could just make energy more efficient or collect it more efficiently, then that by itself gets after the problem. But specifically the point of carbon fiber manufacture, are there ways that we can make it more efficient? How might we do that?
I have no comment on carbon fiber. I'm just kidding. No, I think, believe it or not, and I speak from Toray's perspective, our pressure on sustainable carbon fiber is not coming from aerospace. It's coming from the sports and industrial segment currently. The principal input material or feedstock for carbon fiber is acrylonitrile. It's a petroleum derivative. But you can make acrylonitrile from all kinds of feed. You can make them from biofeedstock. So we have active research projects to source bioacrylonitrile that is manufactured from biofeedstock. That's one lever. The other is the energy used in production. Again, it's not necessarily a technological hurdle as much as it is a cost hurdle. We can source 100% renewable power for our carbon fiber operations today. It's just that we don't yet have a customer that's willing to pay that delta cost. That's not to say that, as some of the other discussions, when those pressures become more collective, that involves our suppliers, such as utility companies, on being able to offer a more diversified suite of renewably sourced power. So in the United States anyway, depending on whether you have a regulated or a non-regulated utility, you can source power from renewable sources today, and greatly lower the carbon footprint of the emissions, the scope 1 and 2 emissions of carbon fiber production today.
Yeah, I mean, there's been effort already going on towards sustainable energy transition with the utilities industry. I mean, I've been working with a few utilities companies myself, where one of the companies that's based in Virginia that supply electricity to their local customers, I think you can guess the name, they've been moving more towards offshore wind turbines. And I think perhaps, again, because of my bias towards digital twins, I'll come back to that. So traditionally, all these gas distribution systems have all not been well maintained. There is a lot of problems around that realm, but they're getting into newer streams like solar and wind. And so in terms of just commissioning some of these systems can be very, very challenging, and can involve a lot of transportation costs, can involve a lot of fuel, burn rate, etc. And so I think part of what digital twin can bring to the table is to, one, go through virtual commissioning of all kinds of systems, be it solar, wind, any sort of renewable or a non-renewable energy source. But then you can also use digital twins to model the process, not just an individual product, right? And so you can save out on a lot of fuel costs, save out on a lot of equipment cost, and so on and so forth. So that's another, perhaps slightly related but connected direction.
Thank you. So here's one maybe coming from a different angle, and Ed, I think I'm going to come specifically to you, since this is something that's near and dear to your heart as far as your subject matter expertise. So how do we get more recycled and recyclable parts into airplanes? What are the challenges that we need to overcome, and what are the opportunities to address those challenges?
That's a real complex question, I'm afraid. And so I think when we talk about parts on aircraft, we have to look at their life, again, go back to the life cycle performance. If I only have to build one, and I don't have to replace it, that's unobtainium, so I realize that I'm heading in that direction. I'll back off a bit. And so, but I think it really does come down to the life cycle, maybe beyond the aircraft. Maybe, kind of to what Tim was talking about with carbon fibers and composites, the talk about kind of downgrading, downcycling these components, these materials for other uses where the performance requirements are not so high. So you're getting an extended life out of something beyond the original intent. So that is one possibility.
Very good.
If I may, just on a lighter note, why are recycle bins always optimistic? Anybody know? Why are recycle bins always optimistic? Because they have a lot of cans, Yes, we can have a lot of cans. Sorry, so sorry. I see a couple of people rolling their eyes.
Dad joke
so
number one, people. So we're up to one dad joke
And one song.
and one residency audition.
Why should you knock on the refrigerator door before opening it? Anybody?
Don't give up your day job moment?
No, yeah, exactly. Why should you knock on the refrigerator door before opening it? Anyone? I mean, energy efficiency is not the answer, but there could be a salad dressing, you see? So you gotta knock.
That one got audible groans.
All right.
Okay, moving on. Aaron, get control. I'm coming to you for this question. I'm
Okay.
going to ask you to put on your subject matter expert hat. So is there a common definition of sustainability that everyone can work with? If sustainability is different for everyone, wouldn't it be difficult to work together?
That's a great question and a challenge that we all face when we think about sustainability. You know, I listened to the report out on the sustainability workshop that happened earlier in this week, and I would say their definition of sustainability came out different than the one that I read. So it is a challenge, and I think it is something we do need to unify around, and that's where those industry collaborations can help in that. I think a common place that we can look is to the UN Sustainable Development Goals. There's 17 of those. They outline that systems connection of sustainability. They were on Adam's charts earlier. They're cute little colored squares, if you're ever looking for them. And I think that's a great way that we can use as an industry to focus on it. Now, we can't do all 17 at all times. So it does make sense that you think about what are the things that are material to your business, material to your stakeholders within those 17 items to move forward. And there's a thing called a materiality assessment that actually is now getting part of the policy regulations coming. It used to be something you just do. To look at how does items around sustainability impact your business, your stakeholders, and that you impact. And I think that's a great way to look at it. We've done some looks at what we call out within Boeing and what our airline customers call out. You're not going to be surprised that there's a lot of commonality there. Emissions, of course, is going to be something we talk about, but also things like accessibility, increasing our future workforce, things like that we all need to work on together because it's a team sport. Which I think has come out during this conversation.
I might add one to that.
Yeah, please.
Communication and education. That's something that
Absolutely.
I think organizations like AIAA can redouble efforts on for two reasons. One, it's kind of a little bit selfish. Without communication and education in the future workforce, the pipeline of skills necessary to implement many of these goals won't be there. But I think a more fundamental reason is if the flying public isn't educated as to what these sustainability goals mean to them, or if the taxpayers don't understand the value of the investments being put forward for national programs, then I think we fall short of being able to continue the investment necessary. So this kind of idea of broad-based communication and education at a community level, and I say community, I mean national level, and even international level, are going to be necessary to meet our requirements for, global competition, but also to meet the goals of industry and the goals of policy to get us where we need to be in 2030, 2040, 2050. If we are going to, achieve a net zero target by 2050, there's going to have to be broad engagement beyond just the industry impacted.
Yeah, I totally agree. And some of those rules that you were just talking about, and I talked about in my introduction, actually are beginning to define how organizations go after their materiality. So I think it'll help us have a more common language on how we talk about our definitions of sustainability, and it should really help with that. So what am I talking about? There's a concept in CSRD called double materiality, where previously companies had to look at their materiality just in terms of their financial impact, or the impact on their financial performance of those risks. Now there is a second part of the double materiality that's about impact. And so to your point, companies are going to have to evaluate what is the impact to my customer? How do I get them on board? What's the impact to the communities in which I live and work? Both positive and negative, right? And make sure that that's actually part of their plan. And then the other piece of this regulation that I think is really important as well is it now requires companies to have a transition plan. So understanding that double materiality, understanding the stakeholders like your customers, and then actually having a plan that will help do that education and drive those changes. And all of that is now required to be assured at the same level of assurance. Well, in a few years, it's coming on an implementation timeline, but it will need to be assured at the same level as your financial reporting. So hopefully that will start to drive more common thoughts around what sustainability actually means, right?
Seems like communication and education might be one of those trends that we would want to add on to the map that I think we might have missed earlier.
Good idea.
Agree. So this is maybe a good follow-on question, looking at it through a little bit different lens. So what do you believe, panel, will be the biggest bottleneck in becoming more sustainable in the aerospace industry? How can aerospace corporations do their part to promote research for more sustainable solutions? So I guess I'll maybe start by just offering up that I feel like sustainability is kind of like a new question to the aerospace industry. It's kind of like, I think most of us that have been in the industry or spent periods of our career in the industry, we're familiar with the design for exercises. Well, let's design for cost, let's design for lightweight, let's design for maximum range or maximum payload. Those are kind of the fundamentals of anyone that's been involved in the conceptual design or actually the entirety of the design process. I feel like the question of designing for sustainability really hasn't been asked very often, right? And it's also one that's maybe hard to pose. So maybe that's another way to think about this question is, well, how do we work sustainability as a design for criteria? Any thoughts?
I mean, we were talking about scale earlier.
Yeah.
I think that's even bottleneck, one of the bottlenecks.
I would say if one of the industries that we support for sustainability relative to efficiency of the system and emissions reduction is ground transportation. So pressure vessels for compressed natural gas, and more recently, pressure vessels for compressed hydrogen gas to reduce the environmental burden of the ground transportation system. When you look at where the policy for application of hydrogen, it's mostly Class 8 over-the-road type trucks, long-distance semis, where refueling infrastructure is kind of already defined. The other is medium-duty trucks, so utility vehicles and other fleet-type vehicles that start and stop at the same location every day. That was the same rollout plan, at least for medium-duty, as compressed natural gas because of the infrastructure requirement. But all of that could be achieved with today's technology. There's no technological constraint on implementing or rolling out a full hydrogen-powered Class 8 truck fleet. It's all based on infrastructure and scale.
Absolutely.
And cost. But cost is many times a function of scale. So that's a good example, but I would go back to kind of a more fundamental thought when you teed up that question is, again, defining the problem or defining what sustainability means. Yeah. We talk about it frequently in our day jobs. We have probably a unique lens of defining sustainability, but if you go to the United Auto Workers, or if you go to policymakers in DC, or if you go to a teachers convention, and pose the question, what does sustainability mean? I think you're going to get a variety of answers. So we as an industry, we as a society have to kind of coalesce about what we mean by sustainability because it is a collective effort.
I would agree with that.
Well, so there are lots of questions coming in, requests for another song. So
of course.
So I don't. No, I'm just kidding. There are actually.
I have another song.
Any requests? Yeah. But there are a lot of questions about digital twins.
Okay.
So here's one in particular. Please give specific examples of how digital twinning can increase efficiency. For example, for your Leonardo example, what happened? How did they save money? Saving money, reducing emissions, reducing waste, raw materials. How did it manifest itself at the bottom line?
Yeah, I still see Stephen Alget's here, so I think he might just kill me if I give specific answers to a customer story here, but I can give you some broad responses. And whoever asked the question, please find me or my colleagues, come by the AIAA hub. We have a booth there. Talk to us. We can give you more specifics offline. But I'll give you an example of a recent project that I did with one of the largest automotive customers based in the Bay Area. They have a continuous improvement team that have been looking at leveraging digital twin for essentially predicting the performance of all the assets that go into a manufacturing sort of a setup. So one specific asset that they wanted to essentially predict the remaining useful life on was a compressor system, an air compressor system. All these red and blue lines that go across these robots that help assemble a car, for instance. So historically, they've been dependent on the supplier to essentially provide the maintenance schedules, to provide MRO. But this specific customer wanted to bring that know-how internally and empower their continuous improvement teams to be able to essentially monitor the absolute humidity and the air temperature from the outside environment and use a digital twin model of the compressor to predict the power characteristics, to predict the temperature changes on a two-stage compressor. So we built up a first principles based, if you will, system dynamics model of their plant. And with that, they were able to, again, this is estimated, they were able to save at least $2 million in operating expense every year, just with this one project. And so there are a few other projects that I've been part of, especially with mining companies, and so on and so forth. And once again, whoever asked this question, thank you for that. Please stop by the booth or come find me. I will give you maybe a more precise answer offline. I hope I didn't evade the question and responded to some degree. Yeah.
So a little bit of a pivot. Is sustainability a feasible priority for the military industry? Will the military and commercial industries have different roles in sustainability? If so, how? So I'll maybe, just to put a little bit in context, I did do a little research coming into the panel. I think military has to have a role. USG has to have a role. So the USG is the largest institutional consumer of petroleum in the world. You may or may not be aware of that. DoD consumes over 2.5 billion gallons of jet fuel annually. And of course, SAF has been kind of brought forward as one of the kind of first lines of defense or first responses to that, but it's not going to end. That can't be the whole answer. Mm-hmm. So, panel, what do you think? How does the military industry contribute or participate in sustainability?
I think they definitely need to participate for some obvious reasons, but I think it's going to look a little different. When you look out across the product life cycle for many of the products in the defense space, the B-52s have been flying for how long and plan to fly for how much further? It's going to look very different, and it's going to be a bit of a challenge. And so we will have less opportunity maybe to bring those new technologies in place because they're just going to be in place so long. So we have to look at things like retrofit. How do you retrofit to make them more efficient? How do you do drop-in liquid fuels like SAF and make that work in that environment? It's different. It's going to look very different.
There's a huge interest in DoD, particularly ground forces.
Mm-hmm.
Yeah. Practical fact is 50% of casualties in Iraq and Afghanistan were associated with refueling or resupply.
Mm-hmm.
So when we talk to our DoD customers, particularly ground forces and power generation, there is a strong desire to develop call it a sustainable solution, but a more deployable, combat-ready, and reliable source of sustaining, particularly power, to frontline forces, frontline ground forces especially.
Very good.
And I think this came up on Wednesday's plenary about climate change and impacting our forces, and that we're having more severe weather events. The temperatures are rising in certain places. I know that can impact our rotor aircraft and other aircraft on their ability to land and take off. So it's going to have to be something that's being considered in that space.
Well, and I also think that there's the commonality between commercial and military, I think, also starts at the very beginning of the life cycle with the design, right? The design choices you make early on, you inherit, and then that stays with you throughout the entire life cycle. So, in theory, as we discussed a bit ago, a sustainable solution is also a most efficient solution, right? Which is an end goal of a commercial operator that's trying to maximize their margins. It's the end goal of a military operator that's trying to maximize their performance. So there's a synergy that should exist there, and in a perfect world, I think you're looking for one industry to potentially feed another. Yeah. Which is, to me, also an opportunity. Yeah. So.
Yeah, one more point on that, and we see it in program decisions. If you think about what Secretary Kendall said this week for NGAD, I think across DoD, you're seeing more emphasis on quantifying the program solution to be more aligned with either the threat environment or the geopolitical situation or the mission. The previous acquisition chief of the Air Force, Dr. Will Roper, he really pushed a iterative approach to procurement and applied that to programs. But I think the days of procuring 2,000, 3,000, 4,000 of a particular unit over a 30-year time frame are probably going to become fewer and fewer. And we as an industry are going to have to iterate more quickly, not just at technology, but on being able to match that technology to a program.
Yeah. Good. Well, so believe it or not, we're most of the way through spending 2 hours together. We only have just over 10 minutes left. And what I want to make sure we leave time to do is for Jason and Daniel to take us through a little bit of what is the Sharp Cloud tool kind of highlighted for us. So I'm gonna kind of flag two more questions. One, I'll just kind of give you in advance so you can kind of cogitate on it, which is the diagram depicting the connectivity looks like a spaghetti chart, recognizing that it's what is shown as notional, real world may closely resemble the same complexity. Is there an opportunity for a workout or a Kaizen amongst all the stakeholders to simplify required effort and begin to align overall process to begin to improve speed? So you can maybe noodle on that a bit, and if you and Daniel need a huddle to take us through the results, that would be great as kind of a wind-up. But the last question for the panel, which I find very provocative, is what do we optimize? We're talking about sustainability. What do we optimize?
What do we optimize?
Around sustainability. What is the thing? What's the lever? And I think one of the things we're maybe taking away is, well, there's not one lever. So.
Yeah, I agree there's not one lever, but I do think that there are some themes. One very important theme is one we've talked about with data and awareness and alignment. And just knowing where the opportunities are, where all the technologies are that can impact your ability to deliver on sustainability, and making those choices and having the data at the places where those choices are being made to make the right choice, if you will, to meet your goals. And so the idea of digital twins and the threat of even the data availability to drive that digital twin, where is that? It's with your suppliers, it's internally with your organization, but I think that's one of the biggest challenges and frankly, one of the unlocks that will help us achieve our goals.
I mean, there are several dimensions, I think, to this question. I mean, you can optimize for design, you can optimize for manufacturing, optimize for operations. In terms of optimizing for design, I think even Dr. Ed spoke about the relevance of modeling and simulation, and so moving more towards a zero physical prototype, reducing the cycle time for physical prototype are all direct, I suppose, value add for sustainability. In terms of operations, I think we spoke about predictive maintenance, being able to optimize the life of the asset, as opposed to just having a reactive mode. I think is another direct lever. I think there are multiple ways to skin the cat, I feel, but you can optimize for design, optimize for manufacturing processes, optimize for operations.
And no cats were injured over the course of today's panel preparations.
Yes.
Well, so maybe we transition,
Yeah.
Jason, to...
Yeah, so going back to the question on speed, it certainly does look like a spaghetti chart, and that's kind of by design because of all the moving parts that exist. Now, when we're working with organizations, like an example is we work with a major asset provider for the Navy, and part of their goal is to increase the production rate. Well, as you start actually looking at these different swim lanes and that landscape that we saw earlier, it's going to be unique to yourself. So if we want to increase production, well, what do we have to do? We probably have to have an outcome internally to reduce outsourcing. We have to improve on-time materials, and that's understanding the supply chain. We need to improve our skilled labor potentially. And so what we want to start doing is, because we see all those connections, we can make a more informed decision when we're actually doing project prioritization. Oftentimes we find it's the loudest voice in the room who wins. So someone is saying, hey, I think we should do this project. This is how much it costs. It's going to have a great impact on our organization. But if we start thinking about those constraints or things that are getting in the way of that outcome, so why do we have this decrease in turnover? Or why are we not able to increase our rate of production today? We can start drawing projects up to those constraints or those blockers. So it flips the conversation and goes back to that idea of the spaghetti chart. Well, if one project is connected to 7 constraints or 7 outcomes, and completing that's going to have X impact, which it can be quantified in the tool, that's where we're going to focus, and it gives us an objective way to make a decision. So as we're prioritizing projects, it's no longer subjective. And as we start looking back at the sustainability landscape that we created, it's the same kind of conversation. When we start looking at innovations that exist today or are coming tomorrow, well, how many regulatory drivers are being impacted by that? How much opportunity is this innovation for sustainability unlocking? And that's kind of the same conversation where it might not be about speed, but it is about impact. And it's those relationships start to tie all of that together.
Is it possible to bring the model up to share?
I can't see from here.
We don't
but
currently have it up yet.
Yeah.
Maybe.
Maybe. As we said, this is an experiment. Thank you for all participating. There we go. It is up.
Is that up?
There we go.
Yep. So here, I mean, if we just look into this, there were some things that we discussed today, such as I know we talked about hydrogen a little bit. So if we would look at the innovation of hydrogen down at the bottom, we can start to see where this ties into the landscape. We can see it has a big impact on net zero, future energy carrier, future proofing, which is something we talked about. We can start to see some of the risks and challenges that might even be associated with it. So it's not all going to be just opportunity. There are going to be risks and challenges, but it's being able to see that and then have discussions and meaningful discussions around that, which I think is impactful.
So one of the things we kicked around, which would be good to get your feedback on in the audience is Jason had mentioned in our discussions, well, it is possible to take a model like this and kind of post it out there,
Yeah.
so that the community can start maturing it and evolving it and probing it. And so that's something that we're considering doing. And I think this thought experiment was really around, well, is this a more collaborative way to have a panel session where it's not just the 4, 5, 6, 7 people on stage, but it's everybody in the room adding their collective expertise as well. And that the panel doesn't just die after 2 hours, right? And isn't just a bunch of meeting notes, but actually is a continuing conversation. So interested in feedback, you can certainly provide it to us, provide it to AIAA, and we can maybe pull the thread on this a little bit more. So with that, I think we're ready for wrap up.
Yeah.
Erin, over to you for thoughts.
Just want to thank the panelists and thank the audience today. You know, one of the things that we said would be successful panel for us is if everyone walked away understanding a little bit more about sustainability and how it is that team sport and how we all kind of have a place to play in this. And as AIA, as you know, Tim was bringing up, how do we make sure that education and communication continues to move forward so we can figure out what the right way is to optimize? So I want to thank you for joining us today and thank the panelists. And if everybody would join me in giving them a round of applause.